My name is Rebecca Burns, and this research is in conjunction with a course completed through the University of Massachusetts under the guidance of my advisor, Alicia Coleman. This project, through the lens of green infrastructure, investigates the far-reaching and site-scale value of a wildlife tracking system installation to the site of a museum in a coastal Cape Cod community. Towns don't want to be suburbs. Suburbs don't want to be cities, and cities don't want to be wastelands. This statement by the Massachusetts politician Michael Dukakis more than 40 years ago is reflected in similar challenges today in small towns, suburbs, and cities. Conflicting land development goals, conservation and open space protection, pollution control, ecosystem sustainability, and climate change threats. Green infrastructure offers solutions. Green infrastructure may be defined as an interconnected network of natural areas and other open spaces that conserves natural ecosystem values and functions, sustains clean air and water, and provides a wide array of benefits to people and wildlife. Specifically, this study examines, through the lens of green infrastructure, the site scale and far-reaching value of a Motus wireless receiver on the site of Chatham Marconi Maritime Center, a museum specializing in wireless technology. The Motus organization is a collaborative international network of scientists tracking wildlife using radio telemetry. Located in a small Cape Cod coastal community, the museum would perhaps be an ideal location for a Motus site and integrative green infrastructure design. The museum engages the public through educational outreach and focuses on the radio telemetry integral to the Motus wildlife tracking system. Also, the coastal town where the museum is located values wildlife conservation. This study considers the Motus wildlife tracking technology, a short history of wildlife tracking, and challenges with data analysis. Using a green infrastructure approach, this study also examines economic and environmental considerations specific to the museum and its location. What educational benefit does wildlife tracking provide to scientists and the public? The main reason that researchers track wildlife are environmental. By tracking wildlife, researchers can monitor endangered species and determine the effects of climate change on wildlife behavior. Additionally, wildlife tracking has public health research applications, particularly in tracking avian behavior, such as monitoring bird behavior to predict the spread of avian flu. Lastly, many scientists and engineers are interested in the data gathered from wildlife tracking, data that can be used to model flight in order to build new, more efficient aircraft. Wildlife tracking is not new. Bird banding may date back to about 200 BCE, when Roman officers tied bands around birds' legs to track them. Today, bird banding is still used as part of citizen science initiatives. During World War II, early radar technologies inadvertently began monitoring birds. Around the same time, scientists began analyzing the composition of feathers to determine where birds were migrating. Radio telemetry is the focus of this research project. It began being used to track wildlife in the 1950s. In the 1970s, scientists began learning how to program computers using machine learning to recognize characteristic features of wildlife such as whales in photographs. Google has recently begun implementing a photo recognition program for whales throughout YouTube. In more recent decades, researchers have made great breakthroughs in developing nanotechnologies that are small enough to track even insects like butterflies. Some scientists have developed satellites that are powerful enough to recognize even individual animals such as penguins from space, as shown in the photographs. Here is one way that many scientists today use wildlife tracking to monitor climate change and endangered species. Understanding where and when these animals feed. Knowledge of how animals use their habitat is important to understanding how they change their use of resources in changing habitats. Within the green infrastructure framework, landscapes are conceptualized as microhabitats, each with its own unique features. This National Geographic map is a model of microhabitats in the United States. Using wildlife tracking, researchers can determine how changes to these microhabitats affect wildlife populations. This study focuses on Motus, perhaps the most extensive international effort to track wildlife. The Motus organization describes its mission as a collaborative approach to radiotelemetry. It is an international network of researchers seeking to gather information on wildlife movement patterns and behavior. Currently, more than 22,000 animals and over 200 species are tracked, mainly birds but also insects and bats. The researchers attach or implant nanotechnology tags in the animals, then use radio technology to track these devices. The data is conveyed to radio receivers and uploaded to a database managed by the Motus organization. With the Motus Wildlife Tracking Project in particular, the data collected has an extremely large scope, with receiver locations all over the globe and over 22,000 animals tracked. However, in order to be useful, this data must be interpreted. Researchers create statistical models in order to eliminate erroneous data and accurately model animal movement. These models must be adjusted depending on factors that might affect error, like the amount of vegetation. A recent study that has employed Motus wildlife tracking technology is in connection with Deepwater Wind, a wind power company. On Block Island in 2016, Deepwater Wind built the United States' first offshore wind farm, about 3 miles from the shore. Following its construction, the University of Rhode Island and the University of Massachusetts at Amherst partnered with the Deepwater Wind Company to lead an initiative to track birds and bats traveling within a 20-mile radius of the site of the new wind farm. The goal of the research is for researchers to learn about how birds and bats react to wind turbine structures. The study received a $299,842 grant from the Bureau of Ocean Energy Management, a subsidiary of the U.S. Department of the Interior. Not every wildlife tracking initiative utilizes wireless technology. Local to the museum site, the Cape Cod Osprey Watch monitors osprey nesting using citizen scientist photography. Historically, osprey populations were almost totally eliminated as a result of the use of DDT prior to its banning under federal law in 1972. Since then, ospreys have returned nationally as well as locally to Cape Cod, an encouraging result of the banning legislation. Cape Cod Osprey Watch is a monitoring group collecting data, especially photos of nests from individuals and schools all over Cape Cod. Participants upload photos and the location where the photos were taken, and researchers make these photos public and list the exact latitude and longitude of each sighting. This research is especially important for the local schools who are major contributors to the project. In some ways, this project is similar to the more extensive eBird project through the Cornell University Lab of Ornithology. With many citizen scientists already involved in wildlife tracking initiatives on Cape Cod, the Chatham-Marconi Maritime Center museum site would be, in the best of all possible worlds, an ideal location for a Motus installation, with its focus on wireless technology and its educational outreach. However, using a green infrastructure approach, it is necessary to think carefully about the ways in which the installation could impact both the environment and the community. As part of this course project, I examined the historical preservation laws in the town as they relate to development. Finally, it is an exciting time for researchers working in the field of wildlife tracking. The global Motus network offers a wealth of data collected by scientists throughout the world. Meanwhile, new advances in artificial intelligence are revolutionizing the study of wildlife conservation, with implications for climate change modeling. As scientists continue to refine and improve their statistical models, new and developing applications of wireless technology will provide insight into the future health of wildlife, sustainable ecosystems, and our planet.